Problem 13, page 683. We have three charges which are located at the corners of an equilateral triangle. We have Q1, Q2, and Q3. The question is calculate the total electric force on the charge 7 microcoulomb. So we have to find the forces applied on this charge. You know 1 microcoulomb equal to 10 minus 6 coulomb. First of all, I have to draw all the forces applied on Q2. Q1 and Q2 have an identical charges, so the force between them is repulsive. So F12 must be out. Q2 and Q3 have an opposite charges, so Q F3 F2 must be in, out and in. Here we have F1 2 and here we have F3 2. This is Q3. So we have to find F at the point 2. F at the point 2 equal F. We have the summation of these two vectors equal F12 plus F32. Now it's important to write this equation. Second, we have to choose the x-axis, the x and y-axis, in which direction you put x and y-axis. It's very important. I advise you to choose x and y in order that to eliminate the maximum of components. For example, if I take the x-axis in this direction and the y-axis in this direction, here we have here we have x and here y. You can choose here y, this one y, and this one x, the same result. We draw the components of each one. F12 has only one component x-axis on the x-axis. F32 has F32y and F32x. And the angle here equal to 60 because it's a equilateral triangle, 60, 60, and 60. So by choosing x-axis, x and y-axis like this, we know the angle. But if you choose another x-axis, maybe you have to calculate the angle, and maybe it's hard to calculate the angle. So it's a good choice. It's important to choose the x-axis and y-axis, in which direction you have to calculate or to do your calculation. So here we can write F12 f1 to x plus f1 to y plus f3 to x plus f3 to y. Okay, we said that f12 has only x component, so we don't have y component. After, we can do the projection in terms of in function of x prime. Now, in function of x prime, what we can say equal, okay, before we can put the values of each one, equal f1 to x in the I direction. It's easy to do the calculation. f3 to x in the minus I direction. So equal minus f3 to x I. f3 to y in the negative in the minus j direction. So minus f3 to y. Now we can calculate the value of each one. Excuse me, here in the direction of minus j. Don't forget, these values are absolute value. Okay, f1 to x equal f1 to cosine the angle between f1 to x and f1 to f1 to x and f1 to the angle is equal to 0. So it's equal to f1 to. Okay, we can write directly its value equal ke q1. Okay, we can put its value directly. q1 equal 2 times 10 minus 6 times q2 equal 7 times 10 minus 6 Coulomb divided by the distance is equal 0.5. We said it's equilateral triangle, so equal square. We can calculate the value. I give you the value of Coulomb constant, and we can calculate the value later. But now it's okay for 1 to x. f3 to x equal f2 3x. It's here. We can see well. It's here. So we can take this triangle. We have an angle here. So to calculate f3x, we have to use cosine 60. Cosine 60 equal f3 to x divided by f3 to equal f3 to cosine 60 equal, we can put its value equal k e q3 equal minus 4 microcoulomb. Don't forget absolute value equal minus 4 times 10 minus 6 times Q2 equal 7 times 10 minus 6 cosine 60 divided by the distance square equal divided by 0.5 square. Okay, it's okay. For f32x, it's okay. For f32y, it's here. f32y, you see well, it's here. It's the same value like this one. So to calculate this one, you have to use sine 60 equal f32y over f32. f32y equal f32 sine 60 equal k e q3 equal minus 4 times 10 minus 6 Coulomb times q2 equals 7 times 10 minus 6 microcoulomb divided by the distance square equal 0.5 square. So finally we can use this equation f2. Okay, we can take a common I. We get here. Okay, I will do the calculation here. I give you the answer. We can write here the answer equal 0.755 I. So what we add this value with this value, we get this answer minus, because here we have minus this value. The answer is 0.436J. So this is the value of f. Okay, we can calculate the magnitude. The magnitude of f2 equal the x component square plus y component square. Okay, we get equal 0.872 Newton. Now, if I ask you to calculate the magnitude, it's okay. So it's important the magnitude. 2. If I ask you to calculate the force vector, it's okay. You have to calculate this equation. Now, if I ask you to calculate the direction of this F, the angle of F equal tangent minus 1 of 1.436 over the y component over the x component, 755. Don't forget on your calculator to put degree, okay? You will have minus, I think, minus 30 degree. What does it mean, 30 degree? Look well here. It's important to see where's the value. Okay, we can see a clear figure. Look, here we have F32, here we have F12. So the total F must be in this region. And if you do here X and Y, the answer is minus 30. It means it must be here. This is equal to 0, here negative, here positive. So this is minus 30. F value at the angle theta equal minus 30. The magnitude is equal to 0.872 Newton. Thank you.